Hello everyone, welcome to my channel. So today we are going to do blind 75, one of the questions, same tree. So far we have completed a lot of trees question, and this is somehow similar to what we have done previously, that inverse or flip tree. There we were checking that whatever is there, we need to just flip it, means swap that. And now here we are checking that if the present left node and the left node of the another tree which is given to us, are those same or not. Earlier it was just a single tree which was there, but now there are two trees which we are to compare. And these questions which are there, these are based for a lot of higher complexity questions. So that's why it's important that we should be thorough enough with these questions. So now comes the part that how we are required to solve this question. So before that, we need to read this question. That's for sure. So here, given the root of a tree, basically two binary trees are given. So here P and Q trees which are mentioned. So here write a function to check if they are same or not. And how we will be checking if they are same or not, right? That is the thing which we need to implement. So here two binary trees are considered the same if they are structurally identical and nodes have the same value. Structurally identical refers to that if there is left node, means basically if there is a tree which has the left node is there, right? So the other tree which is there, that should also have the left node, means structure should be same. If it has the left node, it should also have the left node. If it don't have a right node, then it should also don't have a right node. That's what referred by structurally identical. That's the first thing. Then second thing, and the nodes have the same value. Even the nodes value should also be the same. That is the thing. So that is what we are required to do in this question, that we need to check if both of the trees which are there, those are same or not. So now here first let us check the constraints. So constraints are that the values are from 0 to 100. The values are from minus 10 raised to the power 4 to 10 raised to the power 4, and the number of nodes which are there, those are from 0 to 100. So that means much less nodes are there. And even in the worst case scenario, that is the skew tree, we will be having at max 100 nodes. Yeah. Now comes the part that we will be using BFS or DFS. That is also one of the question. So now here we need to check that both of them are same or not. We need to check the left side and the right side. But here it's about C. 1, then 2, then 3. Then another tree which is there, if it is having 3 and here it is having 2, then that won't make any sense, that both of them are not same. Although structurally they are same, but the values, those differ. So that's why here we will be required to return false. So that would be the thing. So now this thing we are required to code and check the way we were doing in previous, but there it was only one tree. But now here we are having two trees. We need to do the DFS in both of them, and that also at the same time we need to check if when we are going to the left of this particular tree and left of that particular tree, and even the values, are those same or not. So that we need to code, and that we will be returning. So while coding I'll let you know, but the main idea is this only: traverse both of them at the same time, left same time, left for second one, and at same time only we need to check the value. So let us go ahead and code this particular question, and then only we will be able to get that, yeah, this is what we exactly required. So now the first thing is structurally equal and not. For that purpose we need to check if that node exists or not. So for that purpose we need to code that if this particular P which is there, that exists, but if Q doesn't exist at that particular point of time, then in that context that simply means that they are not structurally equal. And the same is the case for the other part, that if P exists but Q doesn't exist. So in that case again it is not structurally equal, right? So at that particular point of time, closing the if condition, so at that particular point of time we are required to return false, because one exists and other doesn't exist. So that's the thing. Now there is one more case that both of them doesn't exist, so that is also the same tree only, that structurally both of them don't exist. So that would be the this case, basically P and Q, both of them don't exist. So in that context we will be returning true. Wait a minute, here Q which is there, it should be P. Yeah, so these are the base cases basically. And now the things which comes into picture is, even in a single line of code we can write, because we need to just check left of both of them exist, right of both of them exist, and values are same. So these are the things which we will be checking, and for that context only I'm just copying this function so that I don't write it again. Although in interviews you shouldn't do that, means some interviewers are like, they don't like this practice. P left exist, Q left exist, so it will return true or false, right? If it returns true, that's good. Then again we will check for P's right exist and Q's right exist. That will also return true or false, and we are putting and condition in between, so that simply refers to that both of these conditions should be true. Then only it will return true as a whole. And in this only itself it is doing recursion also, means calling that original function itself. That is the thing. And the third thing which we were required to check was the value, because these things will check they are structurally identical, but what about the value? That is also one of the condition in the question, right? So that we need to check. So now in that context what we'll do is, we will just check that whatever P value is there, that should be equals to whatever value Q have. That is all. And all these conditions should be in means all these should have and in between, so that all these are true, it will return true. If either of them is false, it will return false. That's the whole thing. And after doing all this, if we check and if we run it, it will pass, because these were the only things which we were required to do. Somewhere I have used it incorrectly. P left, Q left, P right, Q right, and P value equal. Okay, it has this point only. Why this something I'm skipping? But what I'm skipping? P left, P right. The same tree. P left, Q left, P right, Q right. That should be the thing. And P value is equals to Q value. What else they want? Nothing else. Some bracket I'm missing. Let me put hole in the bracket itself. Okay. What is the issue in this whole? We are calling this function, fine. That is all fine anyhow. P left and Q left, which is there. And we are calling this function P right and Q right. That is also fine. The way we are calling, that is also fine. And P value both should be same. That is also fine. And where's the issue? Mm-mm-mm. And why it is the issue now? Let's give a runtime error. Member access within null pointer type. Okay, but I've already made the check that P and Q which are there. If both of them are not there, then I have already mentioned. Okay, fine. Sorry. Here the thing is that I'm required to put or condition, not and condition anyhow, because either of them would be true, not both of them would be true, right? So now if I run, it shouldn't throw runtime error. Yeah, that's the thing. The recursion anyhow, it's something like that also. That whatever means there could be issue in some other line, but you are facing it in some other line. So you need to check each and every line. I was just focusing on this line, which was already correct, but the issue was here. That only I thought that might be there could be some issue with base condition. Then I checked, oh, this is the wrong thing, because either of that condition could be there, not both. That's why. So now this thing, and if we run it, we submit it, it will get accepted, because I have run this question a lot of time. 100% most efficient one. And why it is most efficient? Because this is in the single line, calling of this particular in a single line. That's why it is becoming the most efficient, beats 100%. But I also know that such type of solutions, if we provide in an interview, sometimes interviewers don't like this. So if that could be a case in your interview also, just explain the interviewer each and every step which you have mentioned here and why you have mentioned that the way I was explaining, then most probably they will be good to go. Means they won't feel like it's just a single line or something, because some of the interview don't feel good for this type of solution. And here time complexity order of n, space complexity also order of n. And why space complexity is order of n? Because internal stack which is there, that could store at max order of n nodes, that's why. And the time complexity anyhow, we will be traversing basically order of n, means n nodes, that's why. So this was all for this particular question. If you have any doubt, you could comment that down. And if you feel like we can solve this question by some other method also, or there could be any tweak in this particular approach, or whatever you feel like, it could be like done in some other manner also, some good basically manner, not like brute force or something. Even if you feel like, yeah, you tried this brute force and you were able to figure out that you reached from this brute force to this solution, if something comes to your mind like that also, you can comment. If you have any doubt, basically any doubt, you can comment that down, and I'll reply that, because I get YouTube notifications. I reply instantly only, most of the time, until unless I am stuck in some work, basically my company work or my own learning stuffs or making YouTube video itself, else I usually reply. So this was all. So yeah, thank you.